Hello everybody. Today I'll talk to you about position lines, terrestrial and celestial. Last we had left with the calculation of latitude by taking the altitude at meridian passage. That's the lower and upper meridian passage. How we got it as our latitude and why we calculate all these sites is basically to talk about position line. So when we say that our ship is on a latitude of let us say 30 degrees here, what I'm showing you here, so you should be somewhere on the parallel of latitude 30 degrees north. So now this is a line on which somewhere your position is. So now your latitude has become your position line. If I said the longitude was 30 degrees east, so I'll be on somewhere on the meridian of 30 degrees east, and that is my position line. I'll be on the meridian somewhere. But when I say that my latitude is 30 and longitude is 30, now I have got my position. And there can be only one position of 30 degrees north and 30 degrees east. So to find out my position, I should have two position lines. All lines except parallel lines, which we know when we were in school, they all intersect somewhere or the other. Depending upon what their angle is, how good the cut would be. We had talked about true bearing. True bearing is the angle at the observer between the true north, that is the meridian, and the line joining the observer and the object. So let us just consider this lighthouse here. The bearing is the angle at the observer. Observer is always considered to be at the compass. So his bearing is 60 degrees. True, what you can see here. If the observer was here, this would be his bearing. Angle with the true north. Compass being here now. I'm just transferring it and trying to see what it is. It's 20 degrees. When the observer is here, his bearing is 20 degrees true. So no line drawn from here can have the same bearing. As soon as the observer will move, the bearing would change. The observer, when he is observing the thing at a bearing, he should be somewhere on this line. As I said, as soon as he moves here, his bearing would change. Now this bearing here is your position line. You should be somewhere on this line. The ship must be somewhere on this line. Now not all position lines are straight lines. Some can be curves. If I had a radar and I tried to figure it out and I said it is 5 miles off, then if I draw a circle with 5 miles radius, I would be somewhere on this circle, and then we call this as position circle. Now to get a fix, I should have two position lines. Let's see. This I have taken as 330, 320 here. That's the bearing of this lighthouse here. Another lighthouse here. I get the bearing about 063, and this is my position. So to get my position, to have my position, as I said, we should have two position line, and that is going to be my position. Now this accuracy of this position would be restricted to the bearing what you have measured. Now that depends upon how good your bearing is, how good your compass error is, and other factors which come into play. If the object is far off, then even a small error in the bearing is going to make a big difference in the position. Now if at the same time I had the position circle, I would get my position somewhere here. So as I said, depending upon how accurately you have measured your bearings, your position would be a little bit here and there. Now this accuracy of this position line would increase if the angle between the two observed is big. Because as I said, two lines parallel to each other, not parallel to each other, they will meet somewhere. So depending upon how good the angle is, they might meet in quite a lot of places, they might meet only in one place. If the angle is 90 degrees, they cut exactly at one point, and if the angle is less, let's say 10 degrees, then the meeting stretch would be more. So accuracy would depend upon how big the angle between the two bearings what you have taken. The most accurate bearing what you can take is called a transit line, a transit bearing, when two objects are in a straight line. Here I have just taken these two here. They can be straight line, they can be in straight line only here. If I move here, they will not be in straight line. So a transit bearing would not be affected by any of your factors of compass. Compass error will not play any role, of course. Your observation would. So the most accurate bearing possible is transit bearings. Here, of course, I have taken the buoys. We don't consider buoys because buoys position is now not a certainty. So this is just for an example what I've shown you with buoys here. Now, as I said, two position lines should be required to get your position. Now, bearings, we said, as far as the terrestrial objects go, bearing is your position line. Let's talk about celestial position lines. Now, we did all this just a repeat of finding out your latitude when the sun is on your meridian here, sun on meridian. So when the sun is on the meridian, you usually get this your latitude. Here I have obviously missed out this latitude here. So you can find out your meridian passage time either with 360 and get your exact meridian passage, or you could use your almanac to find out your GMT meridian passage. After getting your GMT meridian passage, you normally go and try to figure out what is your declination, and then you go about using all the errors to your sextant altitude to find out your true altitude, convert it into zenith distance, and then you try to figure out what is your latitude. Now here meridian zenith distance has been given to me as 15 degrees and declination 20 degrees south. And we talked about there are three possibilities. So let us just have a look at the possibility here. Latitude and declination are same, opposite names. This is one of the possibilities we talked about. In this case, zenith distance is 15 and declination is 20. So this possibility does not arise. So we will not bother about this possibility. One possibility is gone off. Of course, this is one of the cases. I purposely took this case just to make you understand this part of it. You might not come across a situation like this. Then the second possibility we talked about was latitude and declination have the same names, and latitude is greater than the declination. As you can see here, latitude is greater than the declination. And I figure out that my latitude should be zenith distance plus my declination, which gives me a latitude of 35 degrees south. The last possibility what we had discussed about was the declination is greater than latitude, what you can see here. That declination is more than the latitude. And in this case, 15 zenith distance, declination 20. So my latitude would be 5 degrees south. Now, how do I figure out which is my latitude, 35 or 5? Of course, this is a hypothetical case because once you are out at sea, you know you are either 5 or at 35. This is only from the examination point of view. So you will be knowing what your latitude is, so one of them will always go off. But how to figure it out as far as the examination point is concerned, you will have the azimuth given to you. So once the azimuth is given to you, bearing south, bearing north, you can figure out which one is the right one. Or you will have your DR given to you in your question to get the answer, in which in this case, of course, I purposely missed out because I wanted to talk to you about three possibilities here. So either way, either azimuth or zenith distance would be given to you in the examinations. So you can figure out which is the correct one. If it is not given, then you have two possibilities here. Now, why did we call this as observer's latitude? Mark my word, observer's latitude, not just the latitude, observer's latitude. Why it became the thing. So let's just start off with geographical position. What is geographical position? We have discussed it earlier also. Here I'm just trying to show you the celestial sphere with the celestial body here. Earth. If I draw a line from the center of the Earth, wherever this line cuts the Earth, that is the geographical position of the body. Now, here is the latitude. When we talked in terms of celestial sphere, we talked about declination. So declination becomes your latitude. And the longitudes are the GHA. So the geographical position of a body is GHA and the declination. So as soon as you started solving this, you had the GHA, you had the declination, you had the geographical position. So now you can go ahead. Basically, everything we are doing it now on the surface of the Earth. Let's have the observer here. Point right overhead is called the zenith, and the zenith distance is the arc of the vertical circle or angle at the center of the Earth that's contained between the zenith and the body. Now this angle is equal to the angle subtended at the center of the Earth between this also, which I had discussed earlier when we were talking about longitudes, because this arc would be in proportion to whatever your radius is here. So this angle, what is there, is also equal to the angle between this and the observer, GP and the observer. Now zenith distance here, 15 degrees, if I convert it into the minutes, then that would be the distance between the observer and the GP. So zenith distance is about 900 miles here. Now with GP as the center, if I just draw a circle like this circle is now my position circle, which we discussed earlier, because all the points on the circle are at the distance of zenith distance. So this is your position circle, and we call this as the circle of equal altitude, because observer anywhere on this circle would have the same altitude of the uh, geographical of the celestial body, of course depending upon what time he's observing it, but the observer body, everybody will have a similar altitude or similar zenith distance. And this I've just projected this circle onto the celestial sphere here. Now this is a circle what we have made with a zenith distance of 15 degrees, which is a circle of about 1600 kilometers. You can figure out here. Now actually you would be knowing where you are Our HE also you should be knowing your DR. Then we know our zenith altitude. So basically we are interested in only a very small part of the circle. And with this circle over this big a radius, a small part of the circle can be taken as a straight line, and you can forget about the curvature of the circumference. It can be taken as a straight line. So these are different observers at different places, and all of them have the same zenith distance because they are lying on the circle of equal altitude. Now, what is the difference here is the azimuth of this body from different observers. Azimuth is what? Is the angle at the zenith between observer's meridian and the vertical circle passing through the body. Now here it is 180, not to this 180. So for an observer at Z1, the azimuth would be 180. For an observer at Z2, Z5, it will be 0, 0, 0 because north, there is no angle being made at zenith. For an observer at Z3, it is north making an angle of 270. And in other these two places, it is nearly southwesterly, here is nearly northwesterly. So, depending upon where the observer is, his azimuth keeps on changing. We know that the radius of a circle, which we have used here as a zenith distance, meets the circumference at makes an angle of 90 degrees with the circumference. That's geometry. Now, as I said, the azimuth here was 180, azimuth 0, 0, 0, 270. Here, of course, azimuth, as I said, somewhere southwesterly here. Now, if I had to consider only the small part of this circle, I could take it as a straight line. And now we have a straight line in all these places. And this is my position line. I'm somewhere on this position line. Because as we said, on the circles anywhere, I was having the same altitude, same zenith distance. So part of it I have taken. So I'm on this position line. But this is what is called my position line. And as you can see it here, that the position line is 90 degrees to its azimuth. Now there's a very fine line of distinction between azimuth and bearing. Azimuths are basically up to 180 degrees on either side, and bearing is 360. And when we refer to celestial bodies, we use the word azimuth. So there we saw that the position line was the bearing. But now when we talk about celestial bodies, the position line becomes 90 degrees plus minus the bearing, the azimuth. So here, it was bearing 180 plus minus 90. My position line is 90 to 70. 90 to 70. Here also 90 to 70. At this place it is running 0, 0, 0, 180. And here it would be whatever the azimuth is here. If it was about 250, 250 plus minus 90, that would be my position line. Now, as I asked you, why did we call it as the observer's latitude? Now, at that particular time when we took the altitude, that time my azimuth was 90. It's either 180 or 0, 0, 0, and my position line was 90 to 70. What runs 290, 090 to 70? is our latitudes. Latitudes run east and west. So the altitude when you take, when the body is on your meridian, you get a position line which is running east and west. So that gives you your latitude. And mark the thing here, observer's latitude. So when the body is on the meridian, you are getting the observers, your latitude. We'll be talking about calculating latitudes in other ways also. But at that particular time, you will not be getting your latitude. Here you are getting your latitude because here your position line is running east and west. So keep this in mind. When the observer was here, at that time, the azimuth was 270. The position line here is running 0180. And what runs 0180 is your longitude. So the observation was made when the zenith or azimuth was to 270 or 90, then I would get my latitude, observer's longitude. As I said, we'll be talking about finding out longitude also later on, but at that particular time, you will not be getting your longitude. You'll be getting a longitude to which you are going to pass your position line. You can get your longitude only if at the time when you take your altitude, you measure your zenith distance, and you have a line bearing as 270 or 090, then you will get your position line which is running 180, and that will be your position line. And in other places here, we'll be trying to find out the position through which to pass this position line, which we'll discuss when we'll be talking about different various ways to find out our other calculations about intercept and longitude and other things. So now this is your geographical position. We talked about this is the declination is the latitude and longitude is the GHA. Now how has become my latitude? If you look at it here, when the body is on meridian, you are actually measuring what? You are measuring the arc of the meridian. So this is just a diagram on observer's meridian. Let's say the observer is here because we know that this is on the south latitude. The body, declination south. And so what we have done when we are measuring the altitude, we measure it along this up to the rational horizon. So when the body was on the observer, what you have actually done is you have measured the arc of the meridian, and arc of the meridian is always either latitude or delatitude. Now then you convert that into zenith distance. You measured this and you converted it by subtracting 90, you converted it into zenith distance. And then you used your declination, that is from equinoctial to the body, and then you've tried to figure out what is my latitude, your latitude from equator to the observer. In this case, as you can see, this is your zenith distance, declination. So you add your azimuth is north, body is north of you. If I just change the observer, now you have declination minus zenith distance gives you your latitude, and the azimuth becomes south here. And that is how we figured out we have two latitudes in this particular example what I solved here. Now this is the geographical position, right? I'm just trying to talk to you about it in a normal sense of when we talked about DLAT and DLOG. Now this is my GP here, and I make a circle with the radius of 15 degrees. I am somewhere on this circle. The body was on my meridian. Now on the meridian, whatever you measure with, as I said, is delat or latitudes, depending upon from where you're measuring. So in this case, when you talked about meridian zenith distance, that's the delat between the GP, isn't it? So what you have basically done to the GP, you have either added or subtracted your delat in this term. If you are conversant, when we talked about delat and delong, and we are getting our latitude because the body is on the meridian. So that particular distance, whatever we are talking about, is either delat or delong. If it was not on the meridian, then that wouldn't be the zenith distance wouldn't be your delat here. Now we talked about at the intersection of 2 points. So now here in this case, I know the GP, I know the zenith distance, I know the azimuth. Can I find out my position? Because we require two things. I have the distance, uh, I have the bearing. So this we will discuss next, along with what is the value of a single position line in the next topic. Till then, thank you very much for being with me.